Okay, okay, let's go. Let's start. Yes, morning 2 hours, 44 sessions. I planned 44 into 2, 88 hours. One minute, please. I'm sorry. Ah, Other subjects I don't know. Road cities 2 classes. Just name will be doubt clearing session, but the class will be 3 phase one. Okay, so general discussion. Let's leave it for some time. Okay, so welcome to the subject. So let's start 8085. Yes, let's crack it. Microprocessors and interfacing. Okay, so please listen here. Some people have difficulty with this subject. Yeah, ready? We can do it. I will upload maybe today. Don't worry about it. Some people have difficulty with this microprocessor subject. Not only in this, in academics also, you will feel some difficulty because of the new terminologies that comes in the what we call subject. Actually, this subject is not much tough. Actually, this subject is not much tough. I Gopi. So subject is easy if you understand. You love this subject also. It is more logical. It is more logical. Okay, more logical. Some new terminology comes. New terminology comes because of that new terminology. People will feel difficult. So in my class, I am saying you every single word I will use. I know it in depth, so you can feel free to ask. Okay, every single line we discuss it. Whatever the level you want, you ask me. I am very happy to help you. Fine. So you will get hardly one question or two questions from this. That is 2 to 3 marks. But effort also less. You need not give much effort as much as you need keep it for your machines or any other communication subject like that. Your effort also 1/4 of that. Is you spend 25 hours, another 20 hours like that for practice, nothing more. In ESC, it will come more. In ESC, object 2, some around 10 questions they are giving. 5 to 10 questions. Okay. But for that, you need 8086 also. I may cover it that part also. Okay. So first we are doing this part. So for 8085 part also, there are questions coming from this. Yeah, for electrical or EC, whatever may be the branch, for ESC also it is required. Okay, so give some important, just attend the classes happily, don't keep anything. Yeah, 86 we don't discuss in this session. In this session, only 85. For gate, only 85 is there. First we complete that part. So just concentrate properly. Feel free to ask me anything. We can start the session. So before that, what we are going to discuss in this course? Let's see. Let me upload the things. So this is what we are going to discuss in your 8085 course, this whatever the time we are having. So first I will give you basics, because people have, please stop that Aditya Sura. Okay, because of this basics, okay, because of lacking of these basics, people don't feel difficulty in this part also. What is the terminology we are going to use? What is the basics of the computer you should know? What is microprocessor? You should know it first properly. What microprocessor is what is microprocessor, what is the job of microprocessor, everything if you know properly, then you will not feel difficult in the remaining topics. So because I told already, isme why you feel difficulty is because of new terminology. Other than that, it is not difficult subject at all. So please see, basics we start. I will give you just some basics of the computer. You may feel something different from our regular EC electrical classes. You may feel some computer class, okay, some basic fundamental class. Don't worry. So today, most probably, we will be discussing only basics. I'll be giving you basics. So if possible, then I will come to 8085 block diagram, architecture, and pin diagram, whatever we call all these things in the second session, second chapter. Then what are the operations to be performed to complete one instruction? Those machine cycles will be discussed. So then we discuss what is the meaning of addressing mode, what are they available in your 8085, then complete instruction set of the microprocessor. So what are the instructions you can give to 8085, how to use them to make some job, that is programming also we will discuss. Then how to interface memory, how to interface IO devices, input output devices to 8085 we discuss. So this is what we are going to discuss in our course. So let's move to the fundamental part. What happened to you, Ritik? It is completed. I told SRAM is left, SRAM and DRAM. Yes, we discussed that. Don't worry. Maybe today or tomorrow, last half an hour, we will discuss it. Yeah, not today, maybe tomorrow. Today is weekend. You need to enjoy. I also in the weekend model. And one more announcement I want to make. Originally, your time is for this 8 days, whatever you are having. So 7 to 9 original timings. Regular class. For microprocessor, if required, I may take 7 to 9:30. Be prepared. Depending on the topic, I may increase also. Okay, not today. Today I will leave you because it is a weekend for you and me also. So remaining days, be prepared for 9:30 also. What is that? It is movie, Ganshu. Oh, I don't know. I will watch. Okay. Fine. So listen here. Okay, I don't know. Gopi, up to August 8th, it is there. Okay, let's move. So the first topic we are discussing is the basics of the computer. Evolution, the processors. So in this, so we discuss one by one. The first one we want to discuss is the first Intel's processor. Intel made it. What is that? It is a 4-bit processor. What is the meaning of 4-bit? We discuss very clearly. Don't worry about it right now. Simply right now you think that it is having a capability to perform 4-bit operations at time. Okay, so this is your first processor. So it is done early days of 1971. Anyone born by this time? At least I didn't born. Okay, I'm not by this time. So some people like big people are there, right? So you can see you may be in your last janma. Okay, then Intel went for 8008. Okay, in 1973. code thread. Then our friend came into picture. 8080, 8088, both are same. Okay, so 8080A. These two are 8-bit processors. These are 8-bit processors. Then 8085 came into picture in 1976. Okay, so this much old processor we are studying. This much old processor we are studying. Yes, immediately you will get it in the mind. Why? Okay. Rohit, the simple answer for processor is whoever processes, that is your processor. Okay, I will explain you that. Don't worry. The meaning of the microprocessor, we will discuss that. Don't worry. So now, why? So the first question you will be getting, why you are studying this 1976 years old processor? Abhi kya i3, i5, etc. came into picture? Very good. The same simple answer. When your BZT is invented, some 1947, I think 51, some 48, I think. Okay, around somewhere. Okay, 47. Okay. As an electronics engineer, I should not forget. Why I am writing wrong? 47. Okay. So he is very years old. Okay. Still you study this or directly you study VLSI? Directly you study VLSI, you understand, or if you study this and this, you go for. There is a logic here. Study BJT, then you go for the FET, MOSFET, like that. Your evolution, you should study it properly. Then you will go for the VLSI. But you are not studying this vacuum tubes these days. Right? These are also old, but you are not studying this. Please understand the logic here, because this is of no meaning right now for us. Okay. So your technology here is related to this. So you are studying this part. Okay. Because I studied 8085 microprocessor long back. So I thought it is very old in IITs and all. There may not be this. But when I went to IIT NMTech also, they are offering 8085 and 8086. 1948 is correct, Ruchita? Okay, yes, John T. Rhodes, you will get this answer. Why not these two, or why not this 4004 for our friend? So this is one way you can say first. Okay, what we call functionally complete processor. It contains interrupt structure, serial IO data, which is not present earlier. All these things comes into picture. That is first functionally complete processor. Your 8085 is a 8-bit processor. This is what we are going to discuss. Because if you know this, believe me, if you understand this properly, you can understand the next process on your own also. On your own also, just to give some 1 week of time, you will be able to understand any process. All are just advancements only. That's why they kept this in your syllabus. Not only here, it is important. So the next one is 8086. I don't remember all the years. Okay, so just leave me from this point. I don't discuss these years. 16-bit, you can Google it if you want. Then 80186 came into picture. 80286, 80386. So this is one. This is the first slide, Sushil. Don't worry. So this is a 16-bit. Because today's introduction, so I am going little slow. These are 32-bit process. 32-bit process. Okay. So then 1978 to, yeah, whatever may be the year. So here, please see here. In this era, what happens is virtual memory came into picture. Like that, one by one, all the advancements came into picture. Okay. So listen here. Some student, this is the fundamental question. Every people will get it. 8085. Why this name is 8085? Why your name is Reddy? Why my name is Shankar? Okay. But here there must be some logic, Nazar. So people will start decoding this logic. Some people said that this 8 is 8 bit, 5 is 5 volts power supply. Like that, they gave story to manage the people. But I don't believe in this answer. It is just a numbering of the series. So it started. Okay, it is just giving some series. Okay. So if you see 86, its predecessor is 885, like that 186, 286, like that. They have made it is a company IC, so whatever they are manufacturing, they are giving the names according to their company policies or course, etc. They are giving that. Okay, so I don't believe in this logic also. It is a 8-bit processor, 5-volt source is required. Okay, so that's what I said. So correct. So 86 is 16-bit, so people will match this as 6. Okay, so people can manage anything so that your answer will be satisfied, but I don't want to give that those kind of answers. Samira, wait, what is the meaning of bits? I will tell. Okay, just leave it. Okay. So what is the significance of 8-bit, 32-bit? We will come to that. For time being, what I am saying is the computer is able to perform 8-bit operation at a time. It is a 8-bit processor. It can handle 8 bits numbers, like this kind of. It can handle an arithmetic operation of 8 bits at a time. This is the easiest answer now I can give. Later when we discuss the structure of the processor, then I will explain what is the original meaning. So then it didn't stop. This evolution is still going on. So what is that? 80486 is there, 586 is there. From this there is a name called Pentium. Okay, after Pentium, you have P1, P2, P3. Then some Pentium V Pro is there. Core 2 Duo is there. Then your i3, i5, i7, and so on. This is the evolution of the process. This is where they started, and this is what's going on right. Okay, so i10. Okay, like that I series is running right now. So if you want, you just Google it. You will get total evolution of the processor. All these are Intel only. We are for every processor there are what we call Motorola processors are there. Different companies will produce different processors. But our syllabus is 8085. Similarly, there is some processor, I think 6000 something by Motorola, which will do similar job. AMD is there. All your mobiles processors are AMD only. Yeah, Qualcomm. AMD not sorry. Qualcomm. Qualcomm is there. Snapdragon is by this Qualcomm only. Okay, so many companies are there, but this is like king. Okay, so what we are this is the evolution of the process. Okay, so listen here. This is the evolution of the process. So now let's go to the next. Let's go to the next part. So what we are going to discuss is this part 8085. So now, yeah, advanced risk machines. Okay, don't deviate risk, etc. Okay, leave that for time being. So the next one, let me give you what we call basic terminology. So what is the basic terminology I want to give you is hardware, software, uh, what is meaning of the program, what is the meaning of instruction, all we discuss it here. Okay, so these are the basics I want to give you, so let's start. So please stop that commenting part when I'm discussing. I don't like it. I don't want to disable the chat because people use it to ask the doubts. Please don't say that, sir, yesterday only you told to make friends, sir. Why are you stopping me? I said to make friends, not when class is going on. Okay, now your friends, now your basic definitions came into picture. So first one is hardware. What is hardware? Hardware is nothing but your physical. I don't want to make these definitions. I don't remember. I don't worry you people to remember these things. Just but understand what is hardware. Physical devices like your keyboard, mouse, whatever you are having in your system, all comes under hardware. Okay, hardware is of no use without software. Software will tell you what to do. Your work is to be done by your computer. Who will make it to be done by the computer? Software will make it to make it done the computer. So what software contains? Say you have some particular software. What it is having? It is nothing but a set of programs. Set of programs. What is the program, sir? Sir, today is a weekend program is there, sir. So similarly here, what is program? Program is nothing but a set of instructions. What program contains? A set of instructions. What is instruction, sir? It is a basic command to your computer to do a particular job. It can be to do add operation. It may be to do subtraction, multiplication, end operation, move operation, whatever may be. To do any arithmetic operation, logical operation, anything. It is a basic command to do a particular job is called as a instruction. Okay. So how to give a command to the computer? How computer understands, sir? If I speak in English, you will be able to understand. Similarly, computer can understand what? Ones and zeros. Sir, computer is having any ear to listen ones and zeros? Computer can have, do it have any ear to listen ones and zeros? This ones and zeros is called machine language. Okay. Will it understand ones and zeros really? No, computer don't understand even ones and zeros, but computer hardware will understand. Yes, these ones and zeros are nothing but voltages required for our digital devices. Your gates, your what we call flip-flops, registers, whatever present in the network requires these ones and zeros, commands, these ones and zeros like a command to make the job to be completed. Is it clear? Your mic is it's here, man. Gopi. Right. So, okay, listen here. Listen here. Let me explain little more on this. Little more on this because you are doing the microprocessor course, so you should know. You should know the internal structure. What happens in the computer full length. So to understand that full length, so what to do? See here. Say for example, you have a decoder. You have a 3 to 8 decoder, or you have 8 to 256 decoder. What is the decoder you are having? 8 by 256. How to design a processor? I am explaining. Okay, how to design a processor. If you are as an engineer, you can make a small project to design a processor using your Verilog VHDL. If you are a CSCV student, sorry, EC student, you can try it. So 8 by 256 decoder is there, for example. So decoder contains how many inputs, man? 8. It will contain how many outputs? 256. So this 8 input combinations from all zeros to all ones will do 256 different jobs. When all zeros comes, this line will activate. This is assigned to some job 1. Similarly, this will be assigned to job 2. Like that, the last person will be assigned with the job n. Okay, or 2 power n, you can say. So like that, necessary hardware will be there here. So when the particular data comes 000100 something came, so that particular device will be activated, that particular job will be done. This is how your computer understands zeros and ones. Okay, clear? So that is what we call machine code. Okay, that is what we call machine code. That is what we call the basic command to do a particular operation. That is instruction, right? So let's go further. Okay, it's a basic block diagram of the microcomputer. Basic block diagram of the. Okay, so this is what we call CPU. This is what we call CPU. These are input devices. Here you will be having some registers. This is general block diagram. Then from that we'll go to the 8085. I'm giving necessary basics to understand 85. Directly I can go to 85. That will make you little difficult. So that's why just necessary basics we are going through this class. Okay. So what we call ALU. So this is the control unit. You might be studying in your basic computer class also. So the memory and your output devices. Done. So this is the block diagram which you have studied in maybe in your school itself. Yes or no? So here it contains a CPU, input devices, oh, output devices, and memory. Okay. So these are the parts of your computer. Now we discuss one by one. Okay, don't be you might be knowing it already, but little required basics I need to give you. Okay, what is your CPU? What is the job of the CPU? Let's understand the first thing. Where is that? 1 minute. I have a slide in it. Just let me. Okay, CPU is the heart of the computer. Or kya? Anything else other than nowadays lungs are more important than your heart? Yeah, brain. Brain is also correct. Okay. So CPU is the heart of the computer. It contains three parts basically: ALU, registers, and control. What it will be having: ALU, registers. For architecture tomorrow, then you should understand it contains all these things or not. Which part belongs to which particular block? You should understand that. So ALU it will be having, registers will be having, and control unit it will be having. So the famous quotation: CPU is the heart, brain, whatever may be, captain of the ship, driver of taxi. You can make your own codes. Pilot of plane, loco pilot of train, whatever you make it. So this fellow is the center of your system. He will only make it. He is like a director of the movie. He is not Jack Sparrow. He is not hero. He is the director. Okay, so he will only teacher of the student. Oh, good. So he is the heart, the center of your system. He will have, listen, let me explain. It has three things to be done. See here. ALU will perform arithmetic and logic operations. Arithmetic operations means addition, subtraction. If in general process you may have multiplication, division, increment, decrement, all comes under arithmetic operations. Logical like AND operation, OR operation, NAND, whatever XOR, whatever, not NAND, XOR, inversion, comparison, all these comes under logical. All these are taken care, the mathematical part is taken care by this ALU unit. Similarly, it will have registers to store the temporary result. To store the temporary results, it will be having registers. And also it is having a control unit which will generate the necessary control signals. What is the requirement of the control signals, sir? Here, suppose see here. You have adder is there, multiplier circuit is there, comparator is there, AND operation circuit is there. Like that, n number of boxes are there here. But at any given time, depending on your instruction, only one box or two box may need to work together. Remaining should be disabled according to the instruction. When add is coming, it should do addition operation only. When subtraction is coming, it should do that subtraction operation only. Remaining should not be done. So to do that, this control unit will generate the necessary control signals, so which will activate or deactivate a particular hardware device internally to give the required condition. Everybody understand this? Right. So there is nothing complex or great in this class. It will be easiest part only we are discussing. Yes. Right. So register will store the temporary results. So the control unit will do this job. This is what CPU will do. So what is processor will contain? Say, Sushil, you have attended yesterday's class? Ah, how you make AND gate? I told that. That is our AND gate. It is not your op amp part. Okay. So, yeah, right. Listen, if all these are embedded on a single chip, then it is called your friend, what we call microprocessors. Good evening, Gandhiji. Gandhiji, you should not come late as per your name. Punctuality must be there. Huh. Okay. So if all of them are embedded on a single chip, then what we call it as a microprocessor. Now you are able to understand what is a microprocessor? No problem, Gandhiji. Sometimes it happens. So this is what we call microprocessor. In general, it will do the operation in the starting stage. You can say it is a microprocessor because it will perform its operation in microseconds, where your frequency of operation is megahertz. Present days, you can call it as a nanoprocessor also, because it is performing it in nanos. And it is in the thickness of also, earlier it is in microns, and now it is in nanometers. Okay. Yes, good question, Rohit. I will come to that. This is earlier it is in micrometer thickness, so now it is in nanometers. Okay. Rohit is having some doubt. What is that? Chip and memory are different. You are saying asking microprocessor and memory are different or same. That is what you are asking, Rohit. Correct or wrong? Yes. Very simple answer, Rohit. When you purchase any computer, okay. Suppose nowadays you are getting a laptop, everything is embedded in the single laptop. You may not be able to visualize. Suppose you see a CPU, okay. You may be using the processor, Intel processor. You may be using your Intel processor, but memory is not part of processor. He will ask you, sir, how much you want, sir, 500 GB you want, or 250 GB you want, whatever you want, he will ask you. Okay, so processor will not contain the memory. If you say motherboard, that is different case as if board contains memory, sorry, your processor and remaining components also, maybe your RAM, etc. also. Okay, your RAM, etc., maybe there. So processor is only this part. Only this part. Okay, processor contains memory. Which memory? Register memory, that is volatile memory. Temporary memory you will be having. Okay, so in the for the processor, yesterday class I have already discussed, but okay, electrical people are not there yesterday. Um, Listen here, there is in this memory you will be having different primary memory will be there, secondary memory will be there. There you will be having RAM, ROM, etc. You will be having all the different types of memories in this. Okay, so if it is a microprocessor, one small important object I am saying is the microprocessor does not contain any memory other than registers. But if it is a microcontroller, you might have studied 8051 microcontroller, which are using in your embedded systems. Okay, controller will contain memory also inside the chip itself. 86 is processor only. If you take a microcontroller, controller contains the memory inside, inbuilt, because their applications are dedicated applications. Okay, let's go further. So this is the job of the CPU. Please understand carefully. I am investing this much amount of time in this part only, this basic part only. Don't neglect it. Understand each and every requirement. Then only you can design the processor. Please understand the intention of the class. If you understand the basics properly, then only you can understand the required content properly. Don't immediately wait for everything. Already we have discussed the subject completely. You will be knowing about me, but generally I am saying don't expect everything in the single class. You will be getting the best. You have already attended coaching, whatever maybe also, no problem. I will show you the different things of the processor to understand the processor very perfectly. I can assure you like never before. That is for sure. But I always suggest those students who don't have any basic knowledge should also understand the class. Okay, so that's why my basics must be as strong as possible. As you are designing, you are going to understand the processor. You should know what is the basic processor requirement. Processor ka specifications kya, what is the job of the processor. These things you should know. Okay, so let's go to the next. So CPU is the heart of the computer, captain of the ship, whatever, driver of the bus. your bike, whatever may be. So all these things are embedded on a single chip. Then it comes out as microprocessor. It is processing your data. It is maybe converting it. It may be doing addition, subtraction, whatever may be. Samira, you asked me the doubt now. You understand now. It is processing your data. Okay. So now let's go to the next part. It is processing the data, Ruchita. Processing the applied data. Suppose you have given some data, it may be in the memory. It is processing the data. Processing in the sense it may be doing addition, it may be subtraction, it may be comparison, it may be manipulating the data. So what it is processing is the given data, which is present in the memory. So ask any basic doubt, feel free. Okay. I'm saying for the new students. Yeah, it is also doing one kind of processing of the operation. It is doing addition. Arithmetic operation it is doing. But we simply say it is an arithmetic operator circuit. Okay, listen here. So this is the basically what we can say the microprocessor job. Microprocessor all are embedded on a single chip. The basic operation of the CPU is to generate the address of the next instruction. So first thing, what is why this generate the address of next instruction, sir? I will explain. Listen. So what the processor will do is, say it is having some data in the memory. Assume these are memory, not ladder. Okay. So some data is there in the memory. Some code is there. Program is there. Okay. So computer will say it is at the location 1, 2, 3, 4, 5, 6, and so on. So what is the job of your CPU? Firstly, first take this. Take this, read it. Okay, read what is there here, read it. Okay, just take it and read it means just take this into some register. Then understand. There is in any computer when it does some job, it has 4 jobs: reading, understanding, then doing whatever required for this part. There is some code here, just read it first. After reading, what to do? Understand. You same, just compare with your brain only. Processor is nothing but like your brain only. Just compare with your brain. So something is given here. First, what you do? You read it. Then what you do? Understand. Then you do the job. Because you are human, you are having a choice. Similarly, you may think whether to do it or not logically. Logical operation is going on. Same here also. Okay, after reading, what is the job you need to do? That is to be done here. After doing the job, update the results. That is store. So you can say this as 4 parts: fetch, decode, execute, memory. So fetch is nothing but an English word, okay, fancy word to read. So don't think something new is fetch means so immediate. Some people will feel difficulty when they see the name of code fetch. Something very strange is coming here. What is the subcode fetch? I'm not able to understand. This English meaning, if you understand, you are able to understand the fetch. Fetch is nothing but reading. Then what to do? Decode it. Decode means understand. According to computer terminology, fancy terminology, it is understanding. Then decoder will generate, as it showed earlier, some decoder, it will generate the necessary control signals to do the job. Same thing. Then do the job. Do the job is what we call execute. काम करना चाहिए. Then write the results, store the results. You have executed now. You may be storing this result in some other memory or same memory location or some registers, wherever you are. You need to store the results. Otherwise, you need to save the results. These are the jobs to be done by the processor. Please listen. What is mean store? M is memory. Memory write back. That is nothing but storing the results. Rohit, is it clear? M for memory. Memory means memory operation. Okay. Read it, understand. Okay. Then what to do? Execute. Do the job and write the data in the memory. Okay. So let's see. Or let me give you one small, what we call. Wait. So computer is never ending, like your brain. It is a never ending. It will never be ideal. Similar to your brain. Just wait, Aman. People wait. I will explain it here. Computer is just like your brain. So first, let me show you with the help of this figure. So when you start the computer, now you will be able to understand. Just listen. Right, Kupul, exactly. Okay. See here. See here. Just wait. I've made it better. Just wait, Amitabh. Let me complete the table, then you can understand it. Okay. Just that's why I'm making this table. You people continue chatting, don't worry. Unless I start the explanation. But once I start, please stop. Today, one new student of mine, it is old student, but here for this class he is new. Gopi has entered. You can welcome him. And Harsh also, Harish, right? Harish also there. So like I need to keep you engaged. You don't want to sit ideal. Same with the processor also. Done. Okay, stop your chatting. We can discuss. What's happened? You went up to, I think, next galaxy and Nepal, etc. Thank you, Sonali. So let's start. So see here, this is what your processor is doing. So this is what your processor is doing. So first it will start. So once you have started the processor, once you start the processor, then your computer should take this now. From this address only it should read. This is the address. This is the content. In where they are in the memory. Okay. So I should know the address, otherwise I cannot do the job. So it will generate the address of the next instruction or next location, you can say, more what we call precisely. Generate address of next instruction. Okay. What happened, Rohit, after studying digital? You're asking what is the meaning of address? What is the address of memory? What is your home address, man? Rohit? Address is to locate you. Address is to locate you. Right? Similarly, to locate the memory, I need the address. No problem. Rohit, you understand? Forget about microprocessor. Microprocessor is nothing new. It is what you have studied. Those blocks are taking and connecting only. It is not something from space. Okay. So in the microprocessor, we have studied how to make a memory, ROM, RAM, etc. Na? So for that, you have input my address pins and output you will be giving the data. So this is what we call address. Address is for your identification. Okay. So listen, right? John T. Rhodes. So generate the address means a computer don't know na from where it need to study. You have n number of books in your library. Okay, you have n number of books in your library. From which book you need to read, or from that particular book, which page you need to start studying. What happened? Lagging is coming. Rudraksh, just refresh, please. Okay. No lag, no lag. Fine. So listen, please. What I'm saying is you have n number of books in your computer. Like that, you have n number of programs. N number of programs are there in your memory. Yes or no? Processor what to do? It should go to one location. It should go to one location. Start reading from there. Start reading from there. So for that, it should know from where it need to read. This job will be done by some circuit. Some circuit. It may be program counter or can be anything that we discuss it. There should be some fellow who is deciding this in the computer. That is, when you are designing the CPU, you should keep it in mind. There will be some person. Some person must be present who will decide what is the next instruction to be taken by the computer. Here, language, okay, is what is this next, sir? Why can't we take present, sir? You will be having this kind of doubts. Don't worry about it. Understand now. So first started. So generate next means immediately what is the address you need to go? Which address, man? So job is given to you. Okay, job is given. Where to go? Where I need to do this? You need to go to this particular place. So computer also same instruction. First go to there. Go to the particular address. Okay, delivery address there. Okay, so in that address it will have some data. Read it. Read that data. That is called fetching. Fetching is just reading. After reading, understand. Okay, that is decode. After decode, perform the job. Perform the job. Do whatever required. Okay, read it, understand, then perform the job, write it in the memory. After writing, what to do, man? After writing into the memory, one instruction R is completed. Then repeat the cycle. Again, generate the next address, read it, fetch it, decode it, execute memory, and so on. You do this job repeatedly. So 8085 processor completes the generate the address of the next instruction, fetching, read the instruction, understand the instruction, decoding, and perform the operation required, execute, and also write the results in memory, or store the results in memory. Okay, so these are the operations will be generally done by your computer. So it will perform the necessary arithmetic and logical operations. It will provides the temporary memory to store the results. Who will provide it? Your registers. It will generate the necessary control signals. That is done by whom? Control unit. So all these together will do this job. Yeah, next will be read by this on its own. Otherwise, if this line is not there, see, if this line is not there, what is the disadvantage? As Bhargavi asked, first instruction it will read, sir, it will complete the job, then it will sit happily. Then you should say again, go read the next instruction, go read the next instruction. Okay, so go read the next instruction every time I need to say it. Why to say it? Generate one program for that also, which will be automatically incrementing. Some simple program to do it is x equal to x plus 1. What is that? Some simple design to make this is you make one circuit which will do x equal to x plus 1, like a counter. Every time, okay, after this particular thing is done, this will give some impulse, then it will do x plus 1. We have studied counters, right? Counter, whenever clock gives, it will give the next count, right? Same way here. You take a counter kind of circuit here. So when the job is done, it will give the clock pulse. Then it will count the next similar job, simple thing. Okay. So once your job is completed, okay, it can have some decision. What we Asif, see here. After this, it can have some decision circuit. Job completed, yes or no. I'm not going through all those things. Yes or no. Job is completed, stop. Not completed, go back. But actually we are not taking one particular program and explaining this thing, so that's why I am showing it as a continuous operation. So continuously, what is the job of the processor? I'm explaining. If it is a one particular program, after this step it will check yes or no. Job is completed, yes. Okay, you might be studying in your basic classes also that particular part. So here what is the difference you are doing is a hardware point of view also you are able to understand. Right. Somebody asked me something about control signals, sir. What is the meaning of control signals? Listen here. Here I told already. If you have ALU, it contains several parts. It may be having adder, subtractor, multiplier circuit, end operation, comparator circuit is there, complementary circuit are there, different circuits are there. When a particular instruction comes, ALU will be connected with one or two devices. ALU will be connected with one or, in the ALU, you will be having different blocks. In that, we may be using one or two blocks according to the instruction. When add comes, it should do the job of add only. When subtraction comes, it will activate the XOR gates and it should do the subtraction. So that is done by whom? Control unit. So you remember this or not? You have a adder circuit. You have given first input as it is. Second input is given via XOR. We give that XOR is having one name, what? Control signal. When control is 0, addition. When control is 1, subtraction. Same here also. Computer will give you necessary control signal such that which operation is to be done by your computer. It can be arithmetic, it can be logical, it can be anything. Right. Roads, I told already. You might miss the catch. After this, you can have one block whether job is completed, yes or no. If job is completed, then it will stop and start fresh. It depends on the decision block. right? Otherwise, generally, as long as the processor is on, it is having, suppose your system is on, your system is on. When system is on, still some job is done, it is still having some job to do. It will be continuously, it will be thinking kind of more. It is not doing anything, it just displaying some result. It should keep it should retain it. So computer never sleep until you switch off it. Mathematical part it may not be doing, okay? So some decision blocks will be there after this, which will decide that. Once a job is done, it may stop and start a new job, go for the new job. I'm not going through that particular case. This is what it will do generally, right? So let's go to the next. So what we discussed just now is only this box. These two boxes are there and this box is also there. Let's discuss these things firstly, because our concentration is this only. We discuss little more on this. These fellows are our peripherals, you can say. But what are your peripherals, we should know. Let's discuss a little part about it. See here, KL, it depends on the program. Some results will be stored in registers, some results will be stored in the memory. If you store in results in registers, power is gone, this data will be lost. If you store it in memory, depending on the type of memory, even power is lost, there is a chance to store it permanently. So depending on the program, if it is a temporary result, some case you may be storing it in register only. In the total program, you may be taking one instruction which you add, use this to add the next also. So temporary results always stored in registers. Permanent results in general stored in memory. Okay. Saurabh, it is done. You can watch the what we call recorded part. For Hindi batch, I will start after my networks. Okay, done. So where we are, we came to input devices. So input devices, we don't discuss much about it. I mean, our job is to discuss much about the processor, but processor will work by giving inputs only. So via which devices you are giving input to the system, that is nothing but input devices. For me, this is an input device, right? I'm writing using this board. This is also an example of the input device. Okay, so like that, keyboard, your mouse, your plot, whatever the pen, all comes under input devices. You want to see it, Aditya, again? See this board. Whatever I write here, you are able to see it. That is your output. There is a problem. So these are the devices. These are the devices used to input data or program to the computer. Actually, computer in the sense to the CPU, you can say. Next, you can have an app if you want to try this kind of things. There is one app called Virtual Tab. If you have a tablet or mobile phone, from that touch screen can be converted into a pen. If you want, you can try that. So these are the devices used to input data and program to the CPU. So what are the examples? Okay, stop that discussion, guys. So come here. Your keyboard, mouse, your pen, etc. Yes. Namaste, Vishwajit. What happened? You came for visit. So what are the output devices? पढ़ना है तो अभी क्यों आया? वन आवर लेट क्यों? Okay, listen. So these are used to monitor or display the results. What is the use of output devices? Okay, no problem, Vishwa. Remaining part you can see in the recorded part anyway. Tomorrow is also holiday. Fine. So these are used to monitor or display the results. These are used to monitor or display the results. Example is very simple. Any your monitor, visual display unit, your printer, etc. There is nothing more to discuss in this. But why we are having this is we discuss something what we call how to connect them, how to connect these devices to your processor. How to make communication between these two is your job only. How to make input devices, how to make output devices is not your job, but how to make a communication between these two people is our job. That is what we discussed in the interfacing of IO devices. We have a memory and IO interfacing to the computer. So there we'll be discussing how to connect these people to your computer, how to connect these people to your computer. Okay, so in that perspective, we need to study that. Next. The next one is memory. The last one you can say. What is your memory? What is the memory? Different memories you are having. What is that? Yesterday class I gave one memory pyramid also for you. Okay, so here I am giving you RAM and ROM. Okay, this is a read and write memory. Okay, this is read only memory. Why memory is used? Listen. What happened, Sushil? You started quizzing. So memory, it is used to store results, program, etc. Whatever you have. No, that doesn't comes under RAM and ROM. You can say here, okay, you have hard disk and what we call SSD, your solid state external memories. These are okay. This is also external only. These are, oh, please listen, semi-random. These are random access. Okay, then yes, you have some magnetic tapes. These are sequential access. Your floppy, whatever, all disks, CD, DVD comes under semi-random. So how to connect these devices to the computer, we discussed. And here RAM also you have two types, SRAM, DRAM. This is generally what you use in cache memory of the computer. Okay, so generally RAM is used to store the required, suppose you are, please listen, generally these requires little more time, access time is more here, access time is less here. Access time means the time required to read the data or write the data into it. Now magnetic tapes means, Gopi, this one, your tape recorder, remember? Yes, those cassettes, whatever, reels, video cassettes, you know it, you people know it. Oh, it is there in your childhood also. So I'm not much older than you. I should feel like that. Yeah, mostly you don't feel, Vishwa, any difficulty. Okay. So listen here. So here what we are going to discuss is how to connect this kind of memories to the computer. So what are the limitations? What are the limitations? How much you can connect, how much you cannot connect, and all sorts. Okay, Gopi. All these things we'll be discussing here. Okay, here the data is stored in the form of magnetic energy. So your ones and zeros should be stored by some form, which may be some optical form or magnetic form like that. So let's go further. Ah, where we are, right. So the next, what happened here? Gandhi, it is in Telugu language. Just leave it. Till it means you don't know. Okay. Now listen. Let's come to the next one. See here. We have three things to convert or to write program to the processor. You want to write the program to the processor to do a complete job. Okay. We need, okay. So to write the program to the processor, there are different ways. We can classify as high level language, then assembly level language, and direct machine language. Have you ever tried to write the program on machine language? It's not difficult. You can write it. You can write it. You can write, if you know the particular codes, you can convert and write the program. I think if you are, yeah, you can say it is a medium, it is low. No, Vishwa. So assembly is writing in ones and zeros. Suppose you write the program like this. You see sometimes this data in your computer, okay. But if you see in this, what is the difficulty is to debug, to find the errors and all those things we feel difficulty. Computer will understand this easily. Understand the meaning I told her. Now onwards I use it as understand, but you understand what it understand. Okay. So I will say it as I understand. Okay, but you should understand what it will understand. Good. So ones and zeros, it will give you the commands for the your what we call hardware. So, but it is difficult to visualize the program like this. For example, if x equal to 0, do this job, else do this job. This is more understanding for a person. Okay, this is more understanding for us. It is easy to change any error something. Okay, there is another way. X fetch x, compare x, okay, add something. This is kind of it is medium level. This is the low. Okay, move x, copy it. Okay, so here the language you are using is the difference. So people are more lazy. I mean, because of our laziness or your effectiveness of the work are better, it will make to go for this one. So in between there is this one. In between, so finally, examiner, what is that? Your computer will understand this one. Okay, right. So here, so you can write the program in the different ways. So what is the meaning of the high level language? What is the assembly language? What is the machine level language? We will discuss it one by one. So here, please listen here. If it is direct machine language, no need to convert the program. No need to convert the program. Computer ko directly you give it. Okay, at that particular memory you directly write it. Computer will understand when it reads. But here you should have one converter. Here also you should have one converter. What is the job of that converter? What is the job of that converter? To convert this into machine language. So there are two devices. Yes, there are two devices who will do this job. So to convert assembly level, yes, good, language to machine language, we use assembler. Next, to convert high level to machine level, we use American Standard Code for Information Interchange. Like you have a letters A to Z. For computer, A will be given as 65 hexadecimal and Z will be given as 90 hexadecimal. So when 65 comes, the computer will read it as A, or when it displays it as A. 65 in the sense 0. This is one code to give this inputs. The true Vishwa means it is much worse earlier. So to convert high language, we use compile. Okay, there is another thing called I'm not going to the complete computer subject. Okay, so interpreter and compiler. So interpreter is there to convert line by line. Compiler is there to convert totally All those things we are not doing here. That will become a CSC class, computer science class. Okay. Okay. There is no need. Okay, ready? There is no need for that. That's why it may not be used. Yes, Saman, there is a difference. Huh? Your C program is an example of high level language. Your 8085 processor, whatever the program you are writing, this is an example of. This is the C program. This is an example of high level language. Your Java, C++, whatever are there. These are example of high level language. These are example of assembly level language. Got it? Yeah, hex code is for our understanding. Actually, computer don't store hex code. Okay. It is easy for us to write 96 instead of 1001 and 0110. So we write it as a hexadecimal code. Computer fellow, this fellow understand only ones and zero are voltage and no voltage. Two different voltages only it will understand. Okay, this is for our easy representation. We take this hex code. Okay, you write MVI A comma 23H. Simple example without discussing the programming. I am saying is this 23 computer knows only this. But we design internally such that when it comes, it should do the job. When it adds this to 35, that is 00. So it should do the necessary job. Like that, we design the hardware. Memory will store ones and zeros only. We read it as this. Very good. So let's go. MP requires assembler. Assembler will not be part of the processor. It is external. Yes, I will come to that. Just wait, Aman. Yeah, ASCII is for your entry, for your data entry, for your keyboard entry to the computer. Okay, from the keyboard, it will go to the storage. Yes, Aditya, it is externally present. Everything is external in the sense it is nothing but a software program, you can say. Compiler can also be a program to do it. I hope you people know earlier some Turbo C you have installed in your processor or not, in your computer. So this is an example of compiler. Guys, right? So that is the example of your compiler. Similarly, MASM is there. That is an example of assembler for 8086. Compiler converts only. It will convert and give it. Well, let's move to the next one. So now let's go to what we call as you people are asking, let me make some table. Guys, right, listen here. So first I will write machine language. Next, assembly and high level. Is it okay? So firstly, program contains in the machine language, your program contains, listen here everybody, what you have in the program? 1 comma 0, ones and zeros. Ones and zeros. Very good. Then the assembly language contains, listen, in this program you will be using English like words called mnemonics. It's not mnemonics, mnemonics. See here, people will, I already told you, people will feel difficulty with understanding this kind of terminology, so they leave the microprocessor subject. Okay, what is you don't concentrate what is the meaning of mnemonics. I see that this is the first time, so it is difficult subject. No. Okay, these are the things you should avoid. Right? So mnemonics is nothing but English like words called as mnemonics or codes. For example, add, move, subtract, etc. Compare. Very good. So the next one, you will have English like statements. If, else, etc. Right? This is your program. What is the basic program contents of what we call assembly and machine level? This is the basic difference. Is it okay? So the next one we are going to discuss the next line. Okay. Program writing. Can you write this program in machine language? Hard. Okay. It is easy. Easy in the sense not everybody will do it. Easy compared to machine language. Sir, you said this particular language is easy, but I'm not able to write the program. Don't ask that. It is easy in the sense compared to this. Okay, relatively. So I will add that term. Relatively easy. Okay, and here it is moderate. Yes. So this is the link, Aman. So this is the next one. So the next again. Okay. Execution is faster here. Okay. Relatively, I'm again using the terminology properly. Relatively slow. This fellow is moderate. Okay. Next. Next one is debugging. Again, new terminology comes. Debugging is bug means what? What is the meaning of bug? Bug means you use for money some fancy language. That's all. Bug is used. I don't have these many bugs also. So posh to impress someone, you should use that. Similarly, to impress us, a debug. Bug is a nothing but an error. Okay. Yeah, it is bugs. Okay. So like that, here bug is some kind of English. You see here, subject is not difficult unless this is difficult. Okay. What is that, Aditya? Bug is nothing but an error. Bug is nothing but an error. Technically, we can say debug means you need to make what we call correction of error. Okay. I don't know this Poka Yoka. You people are more advanced than me. Okay. Oh, it is local language. Okay, fine, fine. So debug is to correct the errors. To correct the errors, it is difficult. It is difficult in machine language. You cannot debug it easily because ones and zeros all fill this totally with ones and zeros. You will feel difficult. Okay, then this fellow is always medium only. Easy. Okay, relatively easy, difficult, and this medium, moderate. You can say this is that debug phase. The next one. Okay, so the next translation, or you can say translator. Translator is not required. Here, assembler. Who is saying good evening now? It is good night, Chaitanya. So we are about to stop the class in 20 minutes. Assembler is required. You need here compiler. Okay, next. Let's see what is the next one. One big advantage of your high level languages, we are coming to that now. Processor dependent. Machine language, yes. This ones and zeros for your particular processor is because for that particular hardware only it will be satisfying that. No. Here this also yes. You write for 8085, it is compatible with that 8085. Compiler will compile the total program at a time. Assembler will do it one by line. That we are not going to discuss much about it. So now compiler, no. You write a C program, you compile that in any processor, it will be same. But you need to have accordingly one compiler. You should have a compiler according to your particular operating system or particular system, whatever you are having, then it will do it. So this is processor dependent, these two. Here it is not dependent. So these are some basics about your different kinds. So in our base syllabus, whatever we are having is this. So we are going to discuss this. Hence, this will give you better understanding of processor. Here high level will give you much more better, but it is more confusing. Ones and zeros cannot give you the better picture. So this will give you better programming skills compared to this one. So I'm sorry. Ones and zero gives you better picture. This is assembly language will give you more better picture of the slider. Okay, here you can understand the processor, all those things, and you will feel difficulty here. When you have difficulty, you will develop more logics. Here everything is ready made, man. In that you should select it and make it. It is not much difficult for us. Yeah, processor hardware is not same, Aditya. You give 0 and 1, every system will work same for the 0 1. I will repeat, Aditya. D mean, yeah, same. Ones and zeros are different for a different system. For a different hardware, it will work differently. You give all ones for one system, it will give something. If you give all ones for some other system, it will do something. Not negative logic, positive logic. Internal hardware itself. You have some decoder, I said. Simple example. Here, for 8085, it may be 8 to 256 decoder, it is having 256 jobs. It need not be same decoder in other computer also. According to its computer, it may be having adder here, it may be subtractor here, it may be having something else, more or less, whatever may be. Okay, so this ones and zeros will be different, changing for every system, every processor. It depends on the internal hardware. If positive, negative is only for the any case it is applicable. It is not related to your processor. Okay, please listen, Aishwarya. I will explain you. Listen here. For microprocessor, all these are applicable. For all these are for processor only. For computer only, now you people are writing these things. So whatever you are having that computer processor, that is only your microprocessor. So these are the three different ways to write the program. First one is by using directly ones and zero. Second one is to use codes like add, move, sub, and another way is to write the program with the help of high level languages. Okay, so as per our syllabus, we are concentrating on this one because examiner want to develop you one particular skill. Examiner want to develop you the skill to make this assembly language programming, which will develop your skills of thinking, logical thinking, etc. Yeah, in lab they kept that because they want you to use it. Tomorrow you may become an embedded system engineer. You may be writing the code in embedded C, or there also mostly you will be using this kind of assembly language. Yeah, Arun, it should be. Yeah, we will see that for ESC. Hopefully I will take it. So where we are, come here, right? Some student is having the doubt of what is the meaning of Arun. It is correct. Yes. Now Samir, processor dependent means okay. It is depending on processor. Okay. Don't say sir you are making it just an English conversion. No, I will explain. See here. You write a program for 8085 in machine language that is applicable only for 8085. Take that code and run it on some other processor of 8086 or 186, it may not work. That is the meaning of processor dependent. Same, you have assembly language program of 8085. It did not work on some other processor of 80186. But you have a C language program you have written on your BTech first year, which is at the time Core 2 Java or something. Now you have an i3 processor on your system. Still, you run that program, you will be able to compile it. Okay, so it is not depending. Once you write this program, you can run on any processor. Necessary compiler according to your system is required. Done? Is it clear? Who asked me that? Is that who asked me? Let's go. Processor dependent. Right. Samir is happy. If you are happy, I'm also happy. Okay, good. Most colorful slide. Yeah, we have 6 colors. I used all the 6 colors. You will refresh from that also. I feel like that. If I'm filled with all blue color, it may not be that much good. What first time Deep, you are attending my class from I think 1.5 months. You don't feel interesting at that time. I'm just getting. I understand. I mean, you are saying about microprocessor. Okay, let's go. Let's go further. Now come to our best friend, that is your 80. So this general discussion. No, this general discussion is completed. Let's revise the things quickly. Let's revise the things quickly. Then we'll go for the 8085 description today. Just 10 minutes we have. Then we can end the class. Tomorrow onwards, we'll be discussing the main things of the processor. So these are the basic things we have discussed here. So the block diagram architecture, this is the syllabus we are going to cover completely. Today we completed the basic part. Then Okay, so some story, some family of your microprocessor story we have discussed. Okay, so like this. Okay, good. Right, now see here the next one. So whatever the language computer understand, we should speak in that language. Okay. So there is no easy way. You should understand the machine code completely, then you should be able to find where the error is there. So you may be asking it so that it may be more effective because it can save the time of the computer. You are asking in that perspective, maybe KL, correct? Actual sense, who is there? The program which will be stored is actually converted into this whatever we call assembly language uh, program that will be having one opcode. You are only writing this program, but in the memory it will be stored like a what we call this machine language only. For this what we are saying is about the microprocessor condition. Okay, now let's come back here. So these are the basic terminologies we have discussed. Hardware is what you can touch and feel. Software is a set of programs. Program is a set of instructions. Then what is instruction? So program contains instruction. Instruction contains a basic command to do the job for your computer. Okay, right. Whatever you are writing here is high level language. For some other person may not be your brain. Okay, now come here. Come here. See here. For what I want to say is, suppose you have English all words. You have also there some set of rules. You cannot join any words and make a particular sentence. Same way, even high level language uses English like statements. There is some syntax to be followed. Okay, there is some syntax to be followed. Accordingly, we will make the program. So as I said, as simple as English, it is not really as simple as English. It is simpler compared to machine language. So these are the input devices, output devices, and this will make your computer. So in that, what we are concentrating is in this part, that is your CPU, central processing unit, right? So it is the heart of the computer, driver of the bus, whatever you can say, you can call it as cute as you feel, pilot of the ship, or what is that, captain of the ship, all those things. Okay. So these are the things present in your CPU, ALU, registers, and control units. If all of them are packed on a single chip, then it is called microprocessor. Guys, right? So this is what the processor job is. Every single step we discussed very clearly: fetching, decoding, executing, and writing back the results. So these are the input devices, output devices. Uh, right? Input devices are where you give the input. I hope at this time Vishwa entered. He commented on my writing also. Then output devices and memory. So to write a program, there are different ways. So to speak to your computer, okay, there are three ways. One is directly speaking in a way computer is able to understand. Another is there is a translator between your computer and you, or there may be a big translator. Different type of translators are there. So some people quoted it as Chinese, English, Hindi, or their mother tongue. Okay, near mother tongue, national language, whatever you can say. First language, second language, third language. Right. So these are the basic things we have discussed. So it is difficult to debug the computer machine language. So we are going for these things. There are auto debuggers. Different things are there. Uh, Software itself will do this debugging or testing. So come here. So now enter into our friend. Who is that friend? 8085. Right. You will be loving this processor if you understand everything, you will be understanding it also. Then you will be understanding how to write the codes. You will be enjoying this like anything. So let's give the features. I will end mostly after the features. Features of 8085. इसमें क्या difficulty? Nothing to remember, man. I am there, don't worry. Okay, this subject is not difficult. Terminology may be difficult. Today you attend from starting Vishwa, you will be feeling easy. And don't remember all these things. I mean, listen here. Don't remember these years and all. This is of no use for you. Okay, don't remember the things. Remember logic, it will help you enough. It will help you. Okay, first fear you will be having, you have around 246 instructions. You need to remember every instruction. It is difficult. No, I will give you logical way to remember that. I will tell you the logical way to remember that. You will automatically will be remembering when you see the program. Don't worry about it. So let's start the features of the process. Features of the process. Okay. Right. Okay. Thank you. You change your profile pic also, Vishwa. So 8085, what happened? Excuse me. My dear Rhodes. Okay. Roti, Makkan, और क्या? So 8085. Actually, I have that doubt. What do you mean by Makkan? But if I ask, you may think that I don't know Hindi. That's why I didn't ask. I know Roti, Makkan, etc. Thank you, Johnny Rhodes. You made my doubt clear. It is a 8-bit processor. Okay, 8085 is a Intel's 8085 is a 8-bit processor. Yes, without asking, I am able to decode something. Feel free to ask any doubt. Right? Correct? Deep? Good. So 8085 is made on NMOS technology. It is made by NMOS. What is NMOS technology? Now you people know it. Yes, I understood. Sushil, I'll give back again. I understand Hindi. I teach also in Hindi, man. Gandhiji. Just kidding. I taught the whole network subject in Hindi already. Vishwa knows it already. Right. It is a 8-bit processor. It is made in NMOS technology, around 3 megahertz. Around 3 megahertz is the clock frequency. And it is having address bus of 16 bits, data bus of 8 bits. Okay, so address is 16, data is 8. Now you people, okay, stop that Amitabh, just wait for 1 minute. These are the simple things I complete, and we can start exact 8085 tomorrow. This is just a simple basics. So it is having around time period of, this is not exactly 3.3 something. So it's a time period will be around, time period will decide your frequency. Okay, around how much it is? 1 by 3.33 microseconds. Right. This is the clock time period of 8085. It is a 8-bit processor. So its data bus size is 8 bits, address bus is 16 bits. What address bus will tell you, what 8 bits set will tell you. So what is the memory capability? Yeah, I am coming to that. What is the memory capability of the processor? Okay, just listen, Aditya. So it is what is the memory capability? It is 2 power 16 into 8. Now you understand what is the meaning of the address and data. It is having 65536 into 8. I will come to your point. 64K into 8. That is 64 KB. What is the meaning of KB? Kilobytes. Now, what is the meaning of this? It is having 2 power 16 locations. Each location 8 bits of data. So your address bus and data bus need not be of same size. Address bus will tell you the number of different locations can be present in your memory. And data bus will tell you at each location how many bits of data is available. This is who will decide your processor number of bits is data bus. You say 32-bit processor, it doesn't mean its address bus is 32 bits. Its address bus can be anything. Okay, but it's what we call data bus will be 8 bits. If it is a 8-bit processor, data bus size will be 8-bit. If you take a 16-bit processor, who will be 16-bit? Data bus will be 16. Simply this is 16, you don't say it as a 16-bit processor. Who will decide this? Data bus only decide this. Why data bus is deciding? Why not address bus is deciding? Tomorrow we will discuss. Because that is where you will be reading or writing or adding the data through the data bus only. Means you have 2 power 16 locations, at every single location 1 byte. Like that 2 power 16 bytes, 64 KB is its memory capability. Just compare with present days, 64 KB is nothing. Earlier days, this is the processor capability. You are having now 1 TB, etc., etc. By virtual memory concepts, etc., even address bus size and your memory can also be different. Yeah, each house may 8 members tha. How many houses are there? Are 2 power 16. Floppy is in 1.44 MB, I think, right? I remember very childhood earlier days. Yeah. So this is the processor capability. Good. So this is the basic of the processor. Now tomorrow we discuss how address bus, data bus, multiplexed, all of those things we will be discussing tomorrow. Anything else you can ask me, otherwise we can end the class. Thank you, thank you. Tomorrow in the sense Monday. Enjoy your weekend. August 8th. Sir, but we want fetch a location. It's a 16-bit. Yeah, that is taken care by address bus. SRAM, DRAM we discussed Monday. Okay, generally its power supply is 5 volts and it is a 40 pin IC also. All these things will come. Anything else? Good night. Right, weekend mode on kar lo. Enjoy your weekend. Happy weekend. We'll meet on Monday. Not much jaunty roads. You will be able to understand. Some little basics are required. I hope that those little basics will be available. I hope you enjoyed the session. New students also. Have a good weekend, my dear students. Enjoy. with safety. Thank you. I'll try Gandhiji. Right now I am watching, I don't know, my mood changes. Old days movies like 1990s and all. After lockdown. Tomorrow you have test, then I need to upload the questions here. Oh, I have some other job also now. In YouTube, or you are trying wherever. I'll try as you told. Okay, guys, good night.